Okay, so I want to see if I can't tell you this very famous story, bringing together what we've discussed about accumulation and magnification. It'll exercise a few pieces that you're supposed to know. And like all of the trivia in this class, it may not necessarily be on the test explicitly, but there will be questions like this topic. Starting in a place called Guam, which is somewhere, I don't remember where Guam is anymore. Somewhere right around here, right there. Guam was critical during World War II. It was as close as we could get um, to Japan during that conflict in the Pacific Ocean. And so the island of Guam was of military strategic benefit to the United States. It's a separate island. It's not part of the United States, but I believe it's one of those protectorates or territories or something. Anyway, a small, beautiful tropical island, has a little bit of fresh water. So Guam has had people living there for a long time. Nowadays, people mostly go to vacation, but Polynesians settled it early. They're called the Chamorro. And they still have like modern Chamorro cultural practices, which is sort of rare for Polynesian cultures. They still have like kids programs, and they still have like dance and celebration. They have this really cool naturalistic calendar, which is sort of common for Polynesians, but this one has been well studied if you're into anthropology. They have ritual carving, just like most Polynesians. In the case of the Chamorro, they make these elevated pots. Um, and Guam was first colonized during like the missionary period. So the Chamorro lived as Polynesians from way before Easter Island, mostly eating seafood and some limited farming until, relatively recently, the missionary period. Fast forward to World War II. The Americans build a military base on Guam, and things got complicated. Right when the island was of strategic criticality, the Americans needed Guam because things were really accelerating against Japan. Right when that started to go down, there were these reports of a mysterious disease that had been seen as early as the turn of the century, but by 1940 had become the leading cause of death for the Chamorro people. And I should point out that it was especially common for young men, age 25 to 40, which demographically is not a population you would see dying easily. Usually people that age are pretty rugged. And there was this big debate. There were these two doctors, Lytico and Bodig, who were arguing in the press to try to figure out what's going on with the Chamorro. It got really tense because the U.S. needed to keep their military base on the island. The Chamorro thought that perhaps they were being poisoned by the Americans, that there was some foul play going on. There were many people on the island who felt like they were being used. And so there was all these interesting tones of like colonization, and we've seen what you Americans do, and maybe we don't want you to have the island. And apparently there was conversation on the US side that if they don't let us have the island, we're just going to take this island. And so things were getting really tense. And World War II was a scary time. And so you can imagine this was a really heated debate. Why are the Chamorro dying of a neural degenerative disease at young ages? The healthiest people in that population, the most robust, would lose control of their body, gradual paralysis. So first they couldn't walk, and then they couldn't use their hands, and then they couldn't speak, and eventually they couldn't control their involuntary muscles, like they couldn't swallow, they couldn't blink. That's a horrible way to die. So I'll tell you a couple of details, okay? And then we'll be done. It's just a few more minutes now. On the island of Guam, there's these big, big bats. Maybe you've seen them in Indiana Jones. They have like a 3-foot wingspan. They're called flying foxes. They're giant. Really big ones, if they grow large, can stand like 4 or 5 feet tall. They're really big bats, and they're dumb as heck. A buddy of mine tried to save one. It started to live in his house. It would fly out at sunset, and every day when it flew home, it would fly into his ceiling fan and get shot against the walls. They're not very smart. They're beautiful, they're big, they're friendly, they're vegetarians. You don't have to worry about them. These bats became a increasingly important part of the Chamorro diet. Because the Chamorro shifted away from seafood and started growing more of their food. And when the Americans came to the island, there was a lot of new American food. The Chamorro got really excited about pork and stuff. And then as the military started to use more of the land, the Chamorro started to sell more of their pork and seafood to the Americans. And so I'll give you an interesting hint. These bats became a growing part of the Chamorro diet through the 20th century. The bats eat the fruit of this one tree. It's a cycad. That tree's like, I don't know, 600 years old. You may have seen cycads in landscaping. They're usually low to the ground, but as they get older, they start to grow this stem. They're really primitive, very, very old plants. So these are fruit bats, and they eat the fruit of that tree. That tree, just interesting for one reason. That tree has a symbiotic bacteria in its roots. I know, you don't have to write this down. But this is one of those bacteria that are common around plants. You know, plants sweat sugar out of their roots so that the bacteria will like living there, because some bacteria fix nitrogen. That should ring a bell. But this particular tree has a particular symbiotic bacterium. Get ready for this. It's about to get interesting. This particular bacterium is toxic to other life forms in the ground, so that they won't eat the bacterium. And the toxin made by this bacterium, get ready, looks like this. And if you've been paying attention yesterday and today, you should know what happened to the Chamorro now. It's on your screen. The hint that you needed is that this toxic chemical is made by bacteria that live in the roots of the tree whose fruit is eaten by the bats who are eaten by the Chamorro. And this toxin has something very special happening. You don't have to speak chemistry, but the reason I'm showing you this example is the College Board could ask you a question like this one, and you would need to understand it. You don't have to speak chemistry, but look at the bottom. I'm just telling you that this is a toxin, and that's all you need to know, because it's got parts and parts and other parts and other parts, and then it's got this right there, a methyl group. And that's supposed to wake you up. You're supposed to go, oh, the carbon, right. If this bacteria makes a toxin that has a methyl group attached, the tree probably thinks it's useful. The tree will probably absorb that toxin into its cells. Those toxins might end up in the fruit where most plants put all their sugars, you know, so that stuff will move the seed around. That guy's about to go move a seed. So the plant tricked them by making it sweet. Sugar is a carbon compound, right? So plants put their sugary carbon compounds into their fruit so that the animal will move its seeds around. You probably heard that before. So boom, there you go. The toxin made by the bacteria is bioaccumulated by the cycad, the tree. And because the fruit is eaten by bats, every year the bats keep eating fruit, they keep eating fruit, and they also accumulate that toxin. Never use it for anything. They can't break it down. This is not something that bats are evolved to digest, but you know, the cells of a bat are stupid and they'll absorb that carbon compound because it looks useful to them. Silly bats. And so you can see here that the bats have increasingly magnified concentration of toxins. And listen, who eats the most at every barbecue that you've ever been to? It's usually not the kids. It's usually not the old folk. You know who it is? It's the people that are working the hardest physically. If you know Polynesian culture, 25 to 40-year-old dudes in Polynesia tend to be pretty big. Think of The Rock, that famous guy that's in movies. He used to be a pro wrestler, has some cool tattoos, makes a weird eyebrow thing. Think of like a whole barbecue full of those guys. I'll bet you that those guys are going to be eating the most bats at the barbecue. Booyah. This is the way that you'll need to interpret accumulation and magnification in the food web. This was a famous case. It was determined that people were eating so many bats that they were magnifying the concentration of this toxin. I think it's called BMAA, but whatever. This toxin was increasing up the food chain until it reached the bats, and then people were eating so many bats that at some point the concentration became toxic inside these Chamorro men. By the way, there was this lady named Rachel Carson who figured out this exact same thing, where the concentration increased up the food chain until it started to affect eagles at the Channel Islands, like Santa Cruz Island, like the one you see out front. Rachel Carson figured this out. She wrote a book called Silent Spring. That has been on the AP test before. Rachel Carson, Silent Spring. And that was based on this data. She noticed that DDT has a carbon, so it accumulates. It accumulates in algae. It accumulates in the primary consumers that eat algae. It accumulates in the secondary consumers that eat the primary consumers. And, you know, predators at the top of the food chain, that's like a giant percentage of the ocean being funneled into these predators. It has since been determined in other predatory birds. There's a famous example about cats and DDT and rats and mice that you could ask Elena Kahn. It's a fascinating story. If you know somebody in Miss Kahn's class, this is an interesting one. It's been found to kill mountain lions in the Great Lakes. Sorry, not in the Great Lakes, in the Sierra. It's been found to affect seagulls in the Great Lakes, dolphins and whales in distant parts of the ocean. Remember the concept. It looks useful, but it isn't. And so the cells will absorb it, but they cannot use it. It just builds up. And every time you go up the food web, there's another step of gathering from all your diet, but keeping it. So it would be like, if I'm a hoarder and I burglarize a bunch of hoarders, I'm going to have a big old hoard, right? Like, what if I'm burglarizing a hoarder every single day? I'm going to accumulate a whole gigantic pile of useless newspapers. And now imagine if there's another level of super mega burglars who burglarizes people like myself. That would be a gigantic pile of newspapers. This is the idea that you magnify by going up the food web. I hope that helped. I'll see you back in class.